In the name of God, welcome back, guys, to Farahwa's website. My name is Masood. I'm a physics teacher. I'm at your service to explain physics curriculum, grade 12. So far, we finished section 1.1 from chapter 1, and we plan to include, let's say, some national exam questions for you after each section. We want to solve the questions have to do with each section after finishing the section itself. And right now I gathered some questions related to the section 1.1. Let's read the question number 1. Question number 1, 1/10 revolution is equal to, let's say, space degree. So let's say which option is true, which option is equivalent to 1/10 revolution, right? Let me explain for you 1/10 revolution. Let me tell you a note. Whenever you look for degree and you observe rev or revolution, so without any, let's say, without any effort, without thinking about any rule, let's say just write 360 instead of revolution. So because one revolution becomes 360 in degrees, it doesn't need to write any rule. That's why 360 multiplied by 1/10, it becomes what? It becomes 36. Because 3 cancels 3, actually. That's why 36 is true. 36 degree. Question number 2. A mass attached to a 50 centimeter string moving on a circular path starting from rest. If it says starting from rest means omega I becomes 0. Complete 43 turns means 43 revolutions, right? Turns means revolution in 1 minute. So we have delta T. This one is radius. And this one is delta theta, 43 turns, delta theta, 1 minute delta T. Find its angular speed. So we had omega initial because it started from rest, but after that it says, eventually said that to find the angular speed at the end of the motion actually, means omega f. We look for omega f. So right now, I'm gonna, let's say, I'm gonna solve the problem for you. Actually, we have some, let's say, some units. None of these units, let's say, is unified, right? None of them is unified. You have to convert them into the correct unit, which is valid in SI. So R is equal to 50 centimeters means 0.5 meters. Whether you divide it by 100, look here. Whether you divide this number by 100 or multiply it by 10 to the power negative 2, it doesn't matter. It's the same. You get the number 0.5 meters, right? Omega I becomes 0. Delta theta becomes 43 turns means 43 multiplied by 2 pi is equal to 86 pi rad. Delta T is equal to 1 minute, means 60 seconds. We look for omega f. So which rule is convenient? Leave R. Don't think about the R actually. Just focus on these values, omega I, delta theta, delta T, and omega f. Which rule is convenient, right, for finding omega f? Let's say delta theta is equal to 1/2 omega I plus omega f inside the bracket multiplied by delta T. Let me bring it, let me pull it up for better seeing the solution. Actually, I told you this rule is convenient. Delta theta is equal to 1/2 omega I plus omega delta T times delta T. So instead of delta theta, you have to write this number, this value, 86 pi. because we had it in terms, we had to convert it into the rad. We converted into the rad and we substituted instead of delta theta. Instead of omega I, we substitute 0 because it starts from rest. And we look for omega f. I write it as it is. Delta t becomes 60 seconds because it says in 1 minute. The motion is taking place in 1 minute, means 60 seconds. That's why. If you multiply 86 by 3.14, becomes 270 in the, let's say, in the left side. And this one, 60. Actually, inside the bracket becomes omega f, because anything plus 0 becomes itself. 60 divided by 2 becomes 30 omega f. So right now, we look for omega f. Omega f becomes 270 divided by the coefficient of omega f. What's the coefficient of omega f? 30. So it becomes 270 divided by this one's 30, not 3. So right now, 1 0 cancels, let's say 1 0. 27 divided by 3 becomes 9 rad per second. So which option is true? Option A is true. Let's move on to another question, which is question number 3. Question number 3, it says radian. So it, let's say, defined the radian. Radian is an angle whose arc length, means delta S, is equal to its radius is equal to r, which is approximately equal to, what? Is radian equal to 53.7, right? Be careful. Is it 53.7, right? Jog your memory, actually. Think about it. Go over it. Is 1 rad becomes 180? Does it make sense, actually? C, 1 over 2 pi rev, or all of the answers are correct. I know that 1 rad is equal to 57.3 degree, not 53.7. So this option is not true. This is the first one. B, 180 is not true because 1 rad is equal to 57.3. The second option is not true. The third one, I have a doubt about this, let's say, this one, because 1 rev, let's say, 1 over 2 pi rev. Let me solve it for you. 1 over 2 pi rev. Substitute 2 pi instead of rev, right? What do you get? 1 over 2 pi multiplied by 2 pi, because 1 rev is equal to 2 pi. 2 pi rad, actually, 2 pi rad, right? So this one, I write the denominator of 1 for it. 2 pi simplifies 2 pi, and the answer will be 1 rad. So this option is true. C is true. Or we can say this one. Actually, I solved it in other way, in 2 ways. Like this one is a new solution, and I solved it for you in other way. Actually, this actually the first relationship, you know, 1 rad is equal to 57.3. You know this one. Other one, 1 rev is equal to 2 pi rad. You know this, right? You know this relationship. I want you to rearrange this relationship for rad. Take out the rad for me, right? Take out the rad and write an equation for rad. I say rad is equal to, so help me. Guess the, let's say, guess the solution. What shall I do right now? What shall I write here? Which one goes down? Which one goes to the numerator, right? I've told you over and over again that anything multiplied by the variable goes to the denominator immediately. That's why 2 pi goes down, and 1 rev, let's say, goes to the numerator. That's why we have 1 rev divided by 2 pi. Compare it with the option C, actually. It says 1 rev divided by 2 pi. It's the same. That's why C is true, right? Let's move on to another question, which is question number 4. It says the unknown quantity in the corresponding table is equal to what? What do we look for here? We have average acceleration, average angular acceleration is given, delta omega is given directly, and we look for delta t. We look for delta t or time interval. Think about an equation. Which equation is valid here, right? I say alpha average. Let me, let's say, write an equation for you. Alpha average is equal to, I want to judge your memory. Guess the equation. Alpha average is equal to delta omega divided by delta t. So what do we look for? We look for delta t, right? Rearrange the equation using cross multiplying actually. Delta t is equal to, which one goes to the numerator? Delta omega, which one goes down? Let's say alpha average. So delta omega divided by alpha average, 120 divided by 6. Like this, 120 divided by 6, and the answer will be 20 seconds. The answer is 20 seconds. One more question. Oh, okay? Oh.